Hello and welcome to the Palo Alto Networks Next-Generation Firewall demo. My name is Neha Kumar and I'm the Senior Product Marketing Manager for PanOS. With me today is Eric Younghans, our Senior Technical Marketing Engineer for Firewall as a platform. Today, we want to demonstrate how our firewalls can help secure your business and digital way of life. Palo Alto Networks' next-generation firewalls provide consistent protection and experience wherever applications, users, and devices reside. Now, whether that's on your network, in the cloud, or mobile. Moreover, network definitions are widening, and the rate and sophistication of cyber attacks continue to rise. Reactive security can no longer keep up. We have introduced the world's first ML-powered next-generation firewall, empowering you to stay ahead of new emerging threats, see and secure your entire enterprise, including IoT, and enable speed and error reduction with automatic policy recommendations. Now, I'm very excited to talk about all the innovations that continue to happen at Palo Alto Networks and would like to invite Eric to talk about our next-generation firewall capabilities and innovations. So let's get right into the demo.
Thank you, Neha. We'll start with a quick overview of the dashboard. Because the dashboard is the first thing an administrator sees when they log in, it is meant to display relevant, at-a-glance information about your next-generation firewall. The dashboard board is modular, provides a number of widgets, such as the General Information widget, which includes information about the next-generation firewall itself, such as what software and content versions are currently installed. Other widgets allow you to assess the resource utilization of the next-generation firewall, which administrators are currently logged in, and whether anyone is working on the configuration. Adding a widget is as simple as selecting the information you would like displayed from the widgets menu. This firewall is part of a high availability pair, so I'll add the HA widget to my dashboard. This will allow me to see operational information about the pair, such as whether the configuration is in sync, and the current high availability state of both this firewall and its peer. And now I have a nice, clean dashboard that gives me, as a next-generation firewall administrator, relevant information that can be ingested quickly before I move on to other operations. The Palo Alto Networks next-generation firewall identifies all applications in the network, performs deep inspection on the allowed traffic to identify and stop malware, vulnerabilities, and other threats. The Application Command Center, or ACC, provides interactive visualization of that data. The ACC has several predefined tabs, each with a focus on a specific type of data. Here we are looking at the Network Activity tab. The widgets on this tab provide visibility into what's happening on the network from several different perspectives. Here we have an overview of the applications that are on the network. The data is presented in a tree map view, with individual applications grouped by category and subcategory and color-coded according to risk. In the tabular data below the visualization, we can get additional information about the application, including description and risk score from the context menu. Next is the User Activity widget, which displays data about the top users on the network. Note that these can be top users by traffic volume in bytes, number of sessions, associated threats, or other metrics listed along the top of the graph. In the data below, we can see at a glance how many threats a user has encountered, how many applications they have used, and other associated data points. As we scroll down, we can see the top source and destination IP addresses on the network. Just below that, we have the Region widget, which shows the top geographical sources and destinations. Configuration of custom regions also allows administrators to define discrete regions for portions of the network based upon IP address, allowing for a higher degree of granularity. You can see here that rather than having all internal addresses coming from the private 10 dot range, we have been able to assign office locations as regions. This allows us to understand, at a glance, which parts of our network the traffic either comes from or is headed to. I won't go through each widget on every tab, but I'd like to specifically call attention to the SSL Activity tab. This is a new addition to the ACC in PanOS version 10.0 and is directly related to the new decryption log type in PanOS. The portion of encrypted internal and internet-bound network traffic grows every day. The first two widgets on this tab provide visibility into how much traffic on your network was identified as encrypted. The Traffic Activity widget shows what percentage of the traffic on your network has been identified as SSL, while the SSL/TLS traffic widget identifies how much has been decrypted as specified by your policy. The remaining, undecrypted portion represents traffic that is a potential security risk, since effective content inspection relies on seeing the unencrypted traffic flow. The Decryption Failure Reasons widget is a useful tool for administrators that are deploying decryption. In this environment, this widget will show all failures, including failures for unsupported TLS versions. This significantly shortens the troubleshooting workflow and can provide a faster time to resolution. The version and key exchange activity widgets provide administrators visibility into which versions of TLS and what key exchange algorithms are in use within the network. This visibility helps the administrator and the business transition from older, less secure TLS versions and key exchange algorithms. It's important to note the visibility provided by the ACC is built on logs generated by the Next-Generation Firewall. No additional software to install or licenses to buy. It simply works right out of the box.
Thank you, Eric, for walking us through the ACC. Can you give us an example of how a network or a security administrator might use the ACC in their day-to-day practice?
Absolutely. Let's start with the application usage widget. In the tree map, applications are grouped by category and subcategory. This visualization is also interactive. I can click on any application, category, or subcategory to filter the widget by that criteria. In this case, because the general internet category accounts for more than half of the traffic seen by the Next-Generation Firewall, I'll filter that widget by that category. The application usage widget is now filtered and shows only applications which fall into the selected category. Within this view, it is immediately apparent that BitTorrent both comprises a substantial portion of the application mix in this category and is also risky, as we can see from the color coding and risk column in the tabular data. At this point, we already have an interesting data point. We can see fairly extensive use of BitTorrent even though it is not an application that is approved for use on the enterprise network. From here, we have a couple of additional questions that we want to answer. First, where is this application being utilized within the network, and who or what is on the other end of the connection? The second question is what policy is allowing this traffic? To answer these questions, we can add BitTorrent as a global filter to the ACC. Doing this will filter the entire ACC, all tabs and all widgets, to show only data where BitTorrent is the application. To do this, note the arrow that appears when we hover over BitTorrent in the table. Clicking this arrow will add our selected criteria to the Global Filters area on the left-hand side of the screen. With this filtered view, we can immediately see the top BitTorrent user on the network is Steven Sharma, when looking at both source and destination user. Scrolling down to the source and destination IP widgets, we see the IP addresses that are participating in this traffic. In the source and destination region widgets, because we configured custom regions for our offices, we can see that the Santa Clara office is both a top source and top destination for this traffic. So far, we have answered the first question. We know which users are participating in BitTorrent, which hosts they are using to do so, and from which offices or regions they are operating. To answer the second question, we can take a look at the rule usage widget. On this firewall, all of our BitTorrent sessions are allowed by a rule named allow web. While this is obviously an allow rule, we'd like to get an idea of what this rule looks like. We can do that by using the global find. Global find is a search tool that allows administrators to find all types of information about the firewall, including specific objects, such as address objects, and where they are used. Global find returns one instance and shows that it is a security rule, which we already knew. But if we mouse over the rule name, we're presented with the information about the rule, including source and destination information, as well as what applications and ports are allowed. We can see here this rule is wide open, which makes it a pretty terrible rule.
So, starting with the application mix on the firewall, we found that we have an unauthorized application on the network, which users are generating the traffic, where the traffic is going to, and discovered a misconfigured rule which is allowing this access.
Precisely. We've uncovered a rule that can potentially cause a security issue. We can also assess and investigate threats that have actually been seen on the network. Let's clear the global filters we have in place and take a look at the user activity widget. As I mentioned before, the user activity widget shows the top users on the network, but right now I don't want to see the top users by traffic volume, but by threat count. This will give me insight into which users are the most risky and potential hotspots on the network. When viewing the top users by threat, we can see that we only have one user that stands out, Marsha Worth. We'll start by promoting Marsha to a global filter so we can get a complete context about this particular user. This is where some of the other tabs in the ACC really come into play. The Threat tab gives us relevant information on the threats that we see associated with Marsha. The Threat Activity tab breaks down the types of threats Marsha has been affected by. This tabular data shows specific threats that were seen. The URL filtering widget shows us the top URL categories and domain that Marsha visits, while the Content Activity exposes the types of files that are sent and received. The Wildfire Activity by File Type widget is particularly useful, as it shows that Marsha has downloaded one malicious file in the last hour. Just knowing that there were malicious files transferred is good, but we can do better. Clicking Jump to the Logs button on the widget will take me directly to the log event from when the file transfer happened. Now here are the files we saw in the ACC. Clicking the Details button on the log brings up a window which provides details on the session, as well as the wildfire analysis report that led to a malicious verdict for the file. The analysis report includes information on how the file behaved under both static and dynamic analysis, including potentially malicious behaviors, what domains attempted to resolve, and any network connections that particular piece of malware made. Lastly, if I select the Blocked Activity tab, I can find information about all of Marsh's activity that we have blocked, which applications, which threats, and which rules are doing the blocking.
So, to summarize, the ACC is a tool that enables administrators to troubleshoot and investigate events on the network by allowing them to pivot around multiple aspects such as applications, users, and IP addresses. Eric, can you show us what an administrator should do if they want to see actual logs rather than summarized data?
Sure, the Monitor tab contains all the log data for the firewall, for everything from traffic and threat logs to configuration and decryption-related logs. Of particular interest are the user activity reports, which provide complete information about a user's network activity, and the SaaS application report, which breaks down SaaS applications in use on the network based on a number of factors, including whether they are sanctioned for use or not. The SaaS application report can be run based upon the user group to help combat shadow IT and ensure that only approved services and applications are utilized.
All this visibility and reporting capability is great, Eric. Now, how do you configure enforcement and threat protection?
Enforcement is configured on the Policy tab. As an example, let's configure a security policy to onboard a new critical finance web application and database. I first start by clicking Add. On the General tab, I can add a name and a description for the policy. I can also add a tag to the policy if I choose. Tags are user-created and help keep the rule base organized. Lastly, I can enter an audit comment. The audit comment is a flexible field used to maintain a per-rule history of changes. Next, I'll move to the Source tab to select which users and devices can access this new application. All of my users will connect to this new application from the Office or VPN, so I'll choose both in the dropdown. For the source address, we have a couple of different options. I can simply list the address space of my users, or I can use an address group. Address groups can be as simple as traditional groups of addresses, or a dynamic address group. The dynamic address group is a powerful construct which builds membership based upon tags. IP addresses can be tagged in any number of ways, including integrating with external sources such as network access control systems or wireless LAN controllers. In this case, when a device connects to both the wired and wireless network in the office, the network access control system associates the Finance Laptops tag to the device's IP address. For the source user, I will allow all members of my Active Directory Finance Users group access to this new app as well. Dynamic user groups function the same way as dynamic address groups, allowing for adaptive user-based policies. Lastly, I have the option to add a source device. This object is new within version 10.0 of PanOS and works hand in hand with the IoT Security subscription. The IoT Security subscription leverages machine learning to not only identify and classify devices on the network, but also provide threat and risk analysis. Classification is performed by taking advantage of the deep inspection the firewall performs. This architecture allows administrators to secure their devices without having the need to deploy additional sensors on the network. I'll click Add to configure a new device object. In the Device Object window, I can choose up to 6 attributes which act as match criteria for my object. In this example, I'll allow only standard corporate finance laptops running Windows 10 to be granted access to this new application. On the Destination tab, I'll choose the zones that host the new app that we are provisioning. The Application tab is where I can add my applications by name rather than simply by port. Because this new application requires several different sub-applications, I'm going to use a tag-based application filter. Rather than attempting to enable applications one by one, I'll create an application filter that matches applications that are tagged as finance apps, and use that filter in my actual security policy. On the Service tab, I'll leave the application default selected in order to ensure that my applications are only using default standard ports, as published by Palo Alto Networks. Administrators no longer need to spend time researching which ports to open for a particular application. The Actions tab is where we can make decisions about how to treat the traffic that matches this policy. In this case, the action setting will be set to allow, but a number of other options are available, including deny, drop, and reset.
So far, we've seen how to create a policy to allow a new critical application for specific users of a group and the devices that we want to allow. But considering this is a finance application, how do we perform a more in-depth inspection of the traffic to secure these finance applications?
The profile setting area is where we assign cloud-delivered security profiles for deeper inspection of the allowed traffic. Considering this is a core critical application for the business, our policy will ensure that this finance application, including its users and data, are holistically protected from both known and unknown threats. First, we assign the antivirus profile, which bidirectionally inspects the allowed traffic for both known and unknown malicious files. PanOS version 10 introduces inline machine learning antivirus, designed to prevent patient zero, blocking up to 95% of unknown, never-before-seen malware with a very low performance cost. Next, we assign a strict vulnerability profile, preventing any known application layer exploits or exploit attempts. The anti-spyware profile inspects all allowed traffic for known command and control patterns or other indicators of an active compromise. The URL filtering profile allows granular control of all web activity, with multi-category control based upon both content and risk. In addition to providing protection against credential theft, URL filtering in PanOS version 10 also leverages trained machine learning models to identify and prevent web-based phishing and JavaScript attacks inline. File blocking and data filtering, two core features of the Next-Generation Firewall platform, identify file types and the content embedded within, allowing only specific file types and content to be transferred. For example, we will not allow executables to be uploaded to this finance application, and also ensure that no social security numbers or other PII is stored as well. Finally, we assign the Wildfire Analysis Profile. Wildfire is Palo Alto Networks' advanced malware analysis and prevention engine. Natively, the Next-Generation Firewall forwards any unknown files, which are allowed by the policy, for full out-of-band malware analysis. If a file is deemed malicious, Wildfire delivers protections globally within seconds. It should be noted here that with Palo Alto Networks' single-pass architecture, packet inspection is performed only once, regardless of how many security profiles or configurations are enabled. Once a single protection is enabled, there is no further performance degradation when additional subscriptions are applied.
So to recap, we can write policies using multidimensional controls such as user, user group, device, and application, all within a single policy. In this case, we created a policy that enables financial applications but restricts the use to specific users and types of devices. All these capabilities and more are core to the Next-Generation Firewall and available on every form factor. We also saw how to apply our industry-leading security subscriptions that are natively integrated into our ML-powered Next-Generation Firewalls to enhance an organization's security posture. Eric, you walked us through the security features that uses machine learning. Can you show our viewers how the machine learning capability helps us address sophisticated cybersecurity threats?
Absolutely. Let's first dive into the new machine learning-based phishing and malicious JavaScript prevention, delivered as part of our URL filtering subscription. If you aren't aware, phishing continues to be a significant threat vector facing both public and private sectors. Adversaries easily bypass legacy categorization-based controls by instructing the web server hosting the targeted phishing page to show seemingly benign content when visited from outside the target organization. Another common tactic is to leverage compromised legitimate URLs, creating a race condition where common URL crawling and categorization is one step behind the adversary. Let's take a look at an example of a targeted phishing page with malicious JavaScript embedded inside, designed to capture their credentials from Palo Alto Networks employees. In this example, this web page looks identical in every way to Palo Alto Networks' single sign-on page when visited from an unprotected resource. After implementing the URL filtering policy to analyze web page contents using machine learning, we can immediately see the results. The Next-Generation Firewall analyzed the page contents in real time and actively blocked the malicious JavaScript contents, completely blocking the user from accessing the entirety of the phishing page. A corresponding log documenting the user, URL, source, and destination, alongside detailed forensic information, is available for both network and security analysts to review.
So, how does a customer who's new to the Next-Generation Firewall even begin moving to this model, given they may have an existing rule set that may be hundreds or even thousands of rules long?
That is a fairly straightforward process. We have a free tool called Expedition, which will migrate rules from your existing firewall. Once your rules have been migrated, you can use the Policy Optimizer to begin implementing App ID-based rule sets. The Policy Optimizer is a built-in tool located here on the Policy tab. It is designed to provide information on the relative hygiene of your rule base. After the migration process, using Expedition, all of your firewall rules will be imported into the Next-Generation Firewall, but they will still be only based on port and protocol. The No App Specified node in the Policy Optimizer is what will help you move to an App ID-based rule set. Clicking on that node will bring up a list of policies that do not have an application specified in the match criteria. In this view, we can see for each of these policies how many applications have been seen and what traffic matches that policy. This policy named allow_SMB is a perfect example. It was clearly created to allow SMB traffic, but by clicking on the app seen link shows that the policy is allowing more than just SMB. Not only is the rule over-provisioned from an application perspective, but we can also see outdated versions of SMB are allowed, which presents a security risk for the business. From here, we can select the application we want to allow, in this case only SMB v3, and decide how we want to handle it. We can add the application to the existing rule, or we can create a cloned rule with SMB v3 included, which will be inserted just above the existing rule. The cloning option is what allows for easy migration to App ID-based rule sets. To further aid in rule-based hygiene, the Policy Optimizer also provides the Unused Apps node, which provides visibility for rules that may be over-provisioned and allow access for applications which aren't necessary. The Rule Usages node will show policies that have not been hit for different timeframes and should be reviewed to determine if it is necessary they remain in the rule base. As customers continue in their practice, they can take advantage of other Palo Alto Networks tools such as Security Lifecycle Review and Best Practice Assessment to ensure that they are getting the most out of their next-generation firewall investment.
So the journey starts with using Expedition to migrate existing rules and import them into the next-generation firewall. At that point, the customer can start using the free inbuilt Policy Optimizer to transition those old port and protocol-based rules to App ID-based rules. Now, once in place, they can then use the best practice assessment and security lifecycle review tools to ensure operational quality on an ongoing basis.
I should also note that the user interface and functionality is the same for all form factors of the next-generation firewall, including virtual and public cloud instances. As you start expanding your next-generation firewall footprint, you will likely want to enable efficient and scalable management through Panorama, our centralized management system. If you'd like to dive deeper into Panorama, take a look at the Panorama demo.
Thank you, Eric, for walking us through the demo. To recap, we learned how to write policies based on applications, users, and devices within a single policy. We also learned how to use tag-based app filters for responding to changes in app consumption and create manageable policies. Network admins can respond to temporary user access requests quickly and easily using dynamic user groups. We also learned that you can prevent known and unknown threats such as phishing campaigns, file-based threats, and exploitation of valid applications with inline machine learning and prevent patient zero. Users can also get visibility and security into their unmanaged IoT devices without the need to deploy additional sensors. We also talked about how our audience can migrate their existing firewall rules to more secure and simpler app-based rules and improve their cyber hygiene. If you would like to see our next-generation firewall in action, you can evaluate it in your production environment for free without making any network changes or impacting your current security operations. Please reach out to www.paloaltonetworks.com/company/contact sales. Thank you for your time.